Hello everyone, welcome back to second part of equation. Last day we discussed about the Vieta's theorem. Yeah, we discussed about the Vieta's theorem, and you know we did a nice problem on it also. A nice problem we did also on it. That was the problem of AM and GM. Remember, na? Yeah. Now, so today what we are going to do? Today we are going to do a new thing called nature of roots. Now you are be saying, what is roots? Roots means the root of plants. Now it is obvious that it is not. It's not the root of plants, it is the root of equations. Root of equations. Simple. Now what is its nature? Its nature is dependent upon a thing called discriminant. Discriminant is a major factor on which it is dependent. What is dependent? The nature of roots. It can be subdivided into how many cases? Yeah. It can be subdivided into 5 cases. Okay, now. And what it is based on? It is based on discriminant and the Hindu method. Or the Sridhanacharya. Remember I told you in the first or the previous lecture only. Now see here. If we talk about the nature of roots, we first have to talk about the discriminant only. If we talk about the discriminant, what is the discriminant? Discriminant is denoted by this delta, is denoted by this delta or simple capital D only. Now, what is this? We know the formula, that is x equals minus b plus minus root over of b square minus 4ac whole divided by 2a. We remember this. Now, x equals minus b plus minus root over b square minus 4ac whole divided by 2a. Now, this b square minus 4ac part is what we call as our discriminant. Only this part decides whether they will be equal, the roots will be equal, unequal, rational, irrational, or real, or even not real, unreal. Just we are going to subjectify it. Just let us move on with the cases. First case. Case 1. Suppose the discriminant is positive or no. Discriminant is greater than 0 and discriminant is a perfect discriminant is a perfect square. Okay. Therefore, what kind of roots? Roots are of the kind that roots are rational unequal and real. Just remember this part. How can you prove these are rational, unequal, and real? Okay, now this is our case 1. Moving on with case 2, we will see the discriminant is greater than 0. No, sorry, let's give an example. For example, 2, 3, 4, 6, like that. These are rational numbers, unequal, not equal, and real also. Now moving on with the case 2. Our discriminant is greater than 0, but discriminant is not a perfect square. Then the roots are irrational, unequal, and real. Want to see some examples? Oh god, I've just egg type something. Oh no. Egg. How to write example? I just forgot. Easy, yeah. Example greatia. Oh, yeah. Example greatia. You know what is example greatia? Example greatia is a Greek word for. Let me write it here. EG is example gratia. It means for example. Remember this. This is very known and it's very good on. I like this. Example greatia. root 2 comma root 3. Root 17 comma root 5 plus 2. Like that. These are both irrational, not equal, and real also. Case 2. Case 3. Case 3 is such that D is equal to 0. Rational, no rational, no irrational. D is just equal to 0. Then if you try to guess, then you have guessed it correct. Roots are equal. Can be rational or irrational. Both can happen. Irrational and real. Why I have not written here that D is something like? Because this rational or irrational depends on B part. B, x square plus bx plus c. This B part it depends on. Okay, na? It depends on this B part. For example, 2 comma 2, root 5 comma root 5, 6 comma 6, like that. These are equal because D is equal to 0 only. Now just check whether I'm seeing them perfect now. If you don't believe me. Next, case 3 gone. Case 4. Case 4. Case 4 states, oh no. Case 4 states that if D is lesser than 0 and D is a perfect square. Now, not like that. The real part is a perfect square. You might be saying what it is. See. Then the roots are rational, unequal, and what? Irrational, unequal, and unreal. You might be saying how? If b square minus 4ac lesser than 0, then see. Let me write it. B square minus 4ac is Dina. Then b square is lesser than 4ac. Okay. B is lesser than root 2ac. Now ac is a non-zero term. AC is a non-zero term. C is a non-zero term. No, I cannot prove it like that. Let me show you. If b square minus 4ac is lesser than 0, then b square is lesser than 4ac. Now, it comes under a root, na? Comes under root. It comes under root. Now, if this part is negative, suppose it is minus 5. What is the square root of minus 5? Any pointed term? Any type of term? Is it a term even? No, no. What can we do? Therefore, it is unreal. The roots are unreal just like this. Okay. Now, we don't write it like that always. We just write it like, hey, why it's not working? We write it as 5i, where I equal to root over of minus 1. Here it should be root 5i. Root 5i, like this. Just understood. Keep it aside. It's very important. Now see, therefore, if you write some examples, becomes 5i, 4i, 6i, 8i, like this, two roots. Case 4, last case. Case number 5, where discriminant is lesser than 0 and D is not, sorry, not D. The real part is not a perfect square. If we write the roots are, what kind of roots it will be? Irrational, nothing except here. unreal, unequal. Nothing except C. Let's try to give some examples. Root 5 iota minus root 5 iota. 1. Root 6i, root 2i. Like that. We have learned all the 5. Now, how does it help us? Without finding the solutions, we can just guess what kind of solutions we will get while solving. This is the help of this. Okay, now on the basis of this, can we do some problems? Let's try. Find the values for m for which 5x square minus 6x plus m equals 0 has non-real roots. How can I do it? Just simple way. Wait. How can I do it? Simpler way. 5x square minus 6x plus m equals 0. Then the discriminant is equal to 36 minus 20m, which is lesser than 0. Why? Since roots are non-real, it becomes 20m is greater than 36, then m is greater than what? 18 by 10, 9 by 5. M is greater than 5, 1.8. This is our answer. Which is our answer? This 1.8. Wait. What is happening with me? I don't know. Yeah, we understood this problem. Next problem. Um, Find the values of alpha. No. Sorry. Not like that. Yeah. See if ax square plus bx plus c has equal roots. Done. It is simple problem. I just gave it from where I don't know. X square plus bx plus c equal to 0. Then the discriminant is equal to b square minus 4ac, which is also equal to 0. Then c equal to b square by 4. Answer. Let me see a test question. Quadratic equations. Quadratic equations. I cannot find one. AMGM problems. Yeah, found a problem. It's a lengthy, just let me copy it down. Mm. So this is our problem. What it says, if the product of the real roots of the equation is lambda and minimum value of the sum of the roots of the equation is mu, the value of mu, where this denotes the least integer function. Now you might be saying, what is the least integer function? Now just see here. This is called the greatest integer function. Suppose greatest integer of 2.8 returns this value only, 2. Greatest integer of minus 1.8, it returns its lesser value, that is minus 2. Means it returns integer. If we talk about greatest integer, this 2.8, then will return the greater value, it returns 3. Suppose it is minus 1.3, then it will return minus 1 only. Least integer means replies with the greatest term, and greatest integer replies with the least term. Funny, right? Just back the video and just think what I've said. Let's try to do it. I cannot even do it. No. Let the find the value of least integer of mu. Mu. It's mu, okay? Greek alphabet, this is lambda. And this is mu. Now this knows the least integer. X square something. Yeah. Let x square minus ax plus 30 equals to a. Then, sorry, not a, as a is already there. Let's take it as p. Then p equals to 2 root over of 2 root over p plus 15. See here, if we add 15, then it becomes p plus 15 and becomes same as this. Now, p square equals to 2p plus 30. Sorry, 4p plus, it should be 60. 2 into 2, 4, 15, 3 into 5. 5 to the 10, 3 to the 6. P square minus 10p plus 6p minus 60 equals 0. P plus 6 into p minus 10 equals 0. Yeah, it becomes a little bit easy. Minus 6. Case 1. Let's take the least value. X square plus ax plus 30 equal to minus 6. X square plus ax plus 36 equal to 0. Mu equal to a. Lambda equal to 36. Case 2. x square plus ax plus 30 equal to 10. X square plus ax plus 20 equals 0. Here alpha plus beta, this is not the least value, therefore I have to write alpha plus beta only. Is a again, and but alpha beta is different, or we can say just lambda only. Lambda is going different. 30, something is happening here, but what it ain't here. There's a only value of mu a. Okay, leave it. How can I find it out? Let's try. It has what kind of roots? Real roots. It is real roots only. Okay. Then which is greater than 0? Yeah, I have an idea. Fine, mu na. Mu is alpha plus beta. Yes. You divide it by 2. It is greater than equal to what? If you take this lambda, square root of 36. Most probably now it will come. Alpha plus beta is nu. Nu by 2 is greater than equal to 6. Nu is greater than equal to 12. Or if we approach it that way, I have to find out the least value. Okay, if we approach it that way, then alpha plus beta by 2 is greater than equal to root over 20. Alpha plus beta is nu only. I told you last year, remember? It becomes root 20 is for 2 root 5. Then mu is greater than equal to 4 root 5. Therefore, minimum of nu is here 4 root 5. 4 root 5, which is equal to 5 is root 5 is 2.236. 2.236 into 4. 24, 12, 13, 14, 8, 9, 8. 8.944. Which implies to if we find the least integer returns the greatest value. What is the greatest value of this? This is 9. What is the answer? 9. Wonderfully big problem. Wonderfully big problem. I love it. So much I had to play my brain to do it. Nu is 9 also. And just let us reveal the answer. Is it correct or not? 9. Oh, मजा आया. If you have not tried it, in the last video I've shown you the APGP type problems. Just go there and see. Now, this problem was not any way related with this nature fruits, which we were doing. But I found this very good. That's why I just gave it. Yeah. Will be what you knew is this, yeah. 9 is answer. I have to think to do it. Yeah. Nature fruits. Okay, there no nature fruits down there. No use of nature fruits. Yeah, most probably I could use the nature fruits part. Let's approach it with. Approaching it with the nature fruits way. nature of roots. Then we got x square plus ax plus 36 equals 0. Then b square minus 4 is, it says real roots greater than 0. A square minus 36 into 4 before 144 greater than 0. Yeah, they can be equal also. Then a square is greater than equal to 144. Then a is positive given, na? The word is, yeah, it's always positive. Then a is greater than equal to 12. This is the first way. Second way, we're doing nature of roots. Nature of roots procedure. Nature of roots, x square plus ax plus 20 is equal to 0. X square plus, no, sorry. Then b square minus 4ac is greater than 0. It says real roots. A square minus 80 is greater than equal to 0. A square is greater than equal to 80. A is greater than equal to 4 root 5. Then in the same way, you know alpha a equals to mu. Then mu's minimum value is 4 root 5, which is equal to 8.944. Then the least integer of mu is 9, which is our answer. You know, this is the nature of roots procedure, okay? This method 2. Yeah, nature of roots is also used to solve it. Madness, anyways, answer. So wonderfully designed this problem. You can get this type of problems in advance. IQ. Awesome. Just practice and keep connected with me. That's all for today. Goodbye. Good night.